Hi there, welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we'll be learning about alkali metals for GCSE chemistry. The question today is there metal found in bananas? And the answer is yes. Interestingly enough, there are trace amounts or small amounts of metal found in bananas. And this is actually helpful to us. A lot of the metals or the minerals found within actually help us to stay healthy. But specifically, the metals I'm talking about are magnesium and potassium. Now, you might be thinking, why is this relevant to the GCSE curriculum? Well, potassium specifically is a metal found in group 1, and at GCSE, you need to know about these. So, alkali metals, like I said, are all metals. They're found on the left hand side of the periodic table, and they're in group 1 because they all contain one electron in their outer shell. We're talking about lithium, sodium, potassium, specifically those three at GCSE. You need to know the reactivity of, but also rubidium, cesium, and francium, which you're less or not likely to use at all because of their increased reactivity and their dangerous nature. So, the physical properties of these elements are that they're soft metals. We can easily cut them. They all have low melting points as we go down the group. And also, as we go down the group, they have increased reactivity, like I say. They also have low densities too, which is why when we do place them on things like water, they actually are able to float. So, let's look at the atomic structure of the three elements that you really do need to focus on. You can see that each of these, the lithium, the sodium, the potassium, they all have one electron in their outer shell. And as the atom gets larger, that electron gets further away from the positively charged nucleus, which is important when we talk about reactivity. And we'll do that in a moment. But speaking of reactivity, what are the types of reactions you need to be aware of? Well, the exam board want you to know about the three reactions. So you need to know how alkali metals react with oxygen, water, and chlorine. And let's talk about that now. Let's start off with water. Alkali metals react with water to produce metal hydroxide and hydrogen. Examples are lithium plus water goes to make lithium hydroxide and hydrogen, and so on and so forth. Now, how do we actually know that that reaction's taken place? I'm saying it, but how would we actually know it if we were to look and do this really in a lab? Well, lithium hydroxide, as the name would suggest, lithium hydroxide is an alkali, it's a base, it has a very high pH. And as you know, hopefully from your studies, you can actually use a universal indicator to check that pH. And if you drop a few drops of universal indicator into the liquid, you'll see that lithium hydroxide, if it's present, it will have a blue or purpley color change, which is actually helpful for us to identify it. And hydrogen gas, well, we can actually collect some of that hydrogen gas, use a lit spin, and we should hear a popping sound. So that's a good way, or a squeaky pop sound. That's a good way of identifying it too. Now, how does reactivity of alkali metals happen, or what happens when they react with oxygen? Well, they form metal oxides. An example being sodium plus oxygen goes to make sodium oxide, and you can see the various other examples there. But we can also look at how the alkali metals respond when we burn them in oxygen too, and we actually do a combustion reaction. So potassium is the most reactive in the three of these examples, and it will actually burn the most vigorously, and we would be able to see a purple or lilac flame. Sodium is the middle reactivity one. It's not as reactive as potassium, but it's definitely more reactive than lithium, and it will form a orangey yellow flame. And as I said, lithium is the least reactive, and it will also form a reddish coloured flame. We can also check the reactivity in a nice simple way as well. Instead of burning them, we can just take a piece of the metal and cut the metal, because they're soft metals, and we'd see that at first they would be shining, but actually over time you'll see that they start to tarnish, they start to dull, and that's because of the reaction with the oxygen found in the air. And you'd be able to see that actually this tarnishing effect would increase. It would actually happen a lot quicker as you go down the group as well. And then last but not least is the reactivity of alkali metals with chlorine. So what we do is we react the alkali metal, say potassium, with chlorine, and we form metal chlorides. And as the name would suggest, metal chloride, it is a salt. So potassium chloride is a salt, and we know that salts are neutral, so that they would have a neutral pH, and we could test that in a similar way as we did before. So how do we explain these trends? Well, one thing you need to know at the GCSE is you need to explain the trends, but you also need to predict them as well. So let's go with the explanation first. All so far we know that all alkali metals have one electron in their outer shell. The reactivity of group 1 metals is as follows. As the atom loses the outer electron, it actually then forms a cation, okay, a positively charged ion. The reactivity increases as we go down the group. To explain this, it's because the atom actually gets larger as we go down the group, and the outer electron is further away from the nucleus. So, the attractive forces that are found in the positive nucleus from the protons and the negative electron charge actually decreases. They're actually weaker because of that distance. And this means that the outer electron is more easily lost and therefore it is more reactive. And the reason it loses that electron, by the way, is so it becomes stable. Atoms want to be stable, they want to have a full outer shell and become stable. We also need to know that actually that's not where it ends. If we want to reach those higher level grades, we need to actually be able to predict what the trends are. So I have some data here, some rough data, and let's have a look. So the melting points, we have lithium, sodium, potassium, and then we have rubidium, which hasn't been um, added in. So we need to predict this trend. Well, we can see that the overall trend, the melting point in group 1 as you go down the group actually decreases. So we would assume that rubidium would be quite much smaller bar on that chart. The atomic radius, we know as we go down the group, it increases. So rubidium's atomic radius point would be much higher than the potassium one, and it would start to increase. You could be asked in the exam to use data to predict a trend for another type of metal. Perhaps somebody has discovered a metal and they want you to predict where in the group it would fit based on the data that they find. These are quite common ways of asking you to apply your knowledge, and it's worth just being aware of the different trends and how that could be asked in the exam. I hope you enjoyed that video. If you did, feel free to comment, like, subscribe, and share this with someone you think might actually benefit from learning more GCSE chemistry. I've been a GCSE science teacher and you have been curious. Thank you so much for your time. If you want more GCSE content, by the way, please check out my channel for other videos. You can comment below and request any. I'm more than happy to do those, specifically if you have any specific content you want covered. You can also find my content on Instagram at the GCSE Science Teacher and on TikTok as well for more GCSE content in terms of biology, chemistry, and physics. Thanks so much, and I'll see you in the next one. Bye.